All right. We're reading locomotive control electric diesel manual GP35 static control from the collection of Tom Gardner from rrflags.org. Locomotive control GP35 static control March 1964. Served the Department of Electric Motive Division, General Motors Corporation, LaGrange, Illinois, United States. Caution, the diagrams used in this handbook are simplified and presented only with the guide explaining with the GP35 control system. The circuit values shown do not necessarily agree with the wiring specific locomotive, although consult with the applicable diagrams when working with the control system. All the troubleshooting adjustment procedures included with the handbook they are intended with the guide. Do not attempt to control the system adjustment using the information presented here. Adjustment procedures appear on the schematic wire drawing covering the specific locomotive and taking precedence over the information presented here. Introduction. The purpose of this handbook is to describe the GP35 locomotive power control system to serve the guys with familiarize themselves with the systems. The major difference between the GP35 power control system and the system of the models earlier than the GP30 Lion. Application of the control of the main generator battery field excitation, control transition from series parallel to parallel, and control steps and percentage of the motor field application control dynamic brakes. 4. Controlling wheel slip under the power while in dynamic braking. The major differences between the GP35 control system and the GP30 control system lie in the number of steps of the motor field shunting employed in the use of the shunting limiting circuit to the control of the percentage motor field show when fields are hot. This control improvises the communication increases traction motor brush life. This handbook is divided into 4 sections. Section 1 covers the main generator battery field excitation. Section 2 covers the transition control. Section 3 covered the dynamic brake wheel slide control. Section 4 covered the information that may be checked within the troubleshooting with the control system. The follow with the step-by-step manner of actual sequence controlling operated simplified with the graphs, schematic wire diagrams that they appear adjacent to the related text. Alright, Section 1, GP35 excitation system. The depth of the GP35 excitation performance of the control system should be understood that while the performance of the control system functions, the adhesion control considerations to allow compatible operation mixed with the consistent with the governor is still the primary energy power output control device. As indicated in Figure 1.1, that the three-phase alternating current with the excitation of the D32 generator battery field is taken with the D14 alternator. The alternator power provides excitation range with the availability system of the auxiliary generator power commutator type load regulators. And auxiliary generator power is used in excitation under the extreme conditions of temperature. The excitation motor is ranged from 0 to 45 amperes. Right, in Figure 1, you see the excitation system block diagrams, the governor, the 567 engine, auxiliary generator, and going through currents to the F67 energy and the load regulator going to the PLR magnet. From the 56 engine to the alternator, the magnetic amplifier with the battery field current, main generator, traction motors, governor, and the governor control. Alright, the excitation range of the 0 to 45 amp is unlike the conditions of the temperature of the G35 and the GP30 of the excitation system, which uses the D14 power wire-wound rheostat to affect the load regulation, has range of the 1.5 to 70 amperes. The extended range may be possibly used with 195 volts from the D14 alternator compared with 74 volts from the auxiliary generator. The D14 alternator current is fed with the rectified magnified amplifier, which is controlled with the polarized relay of the PLR, the power load regulator. A low power load regulator is under the influence of each of the governors. The rectified control current is fed with the D32 generator battery field. The load regulator field is 100 ohms at 100 watt wire wound tapped rheostat that has the function of controlling output magnified amplifier rather than limiting the battery field current directly to the commutator of the type of the load regulator. The regulator is driven with the vane motor similar to which is driven with the commutator type. A single proportional main generator voltage is the generator voltage transducer. Are governed generator voltage transducer. The signal is edited with a similar signal proportional main generator current, which is derived with the generator with the current transducer or the general current transducer. These two signals are then used to control the output of the magnifying amplifier through the polarized power load regulator. Functions of each of these devices described in the following text and diagrams. Figure 1-2 shows one of the three identical reactors together with a three-phase silicone rectifier making up the magnetic amplifier. The function of the three-phase reactors is to control the limit of the flow of the three-phase alternating current through the D14 alternator generator battery. The simple silicon rectifier, in addition with the rectifier of the D14, ensures the current always flows through the rectifier load windings in the direction from 1 to 2 to 3 to 4. Current flowing through the remaining of the three windings, the direction of 7 to 8, 9 to 10, 11 to 12, increasing the flow of the current from in the 1 to 2 and 3 to 4 load windings. Conversely, a flow of the current is in these windings at 8 to 7, 10 to 9, 12 to 1. 12 to 11, decreasing the flow of the current in the load windings. Alright, your battery field excitation reactor has the 1 to 3 power windings, 7 to 8 bias windings, and 10 and 11 and 12 drive control windings. Two types of transductor reactors used on the GP35 locomotive are shown in Figure 1-3. The reactors or type of the figures in 1-3 are used to detect the main generator current, the flow of the alternating current with the AC coil of the current transducer of the governor control transducer. The proportion of the flow of the main generator current with the passing generator current transducer proportional flow main generator current with the pulse passing with the reactor core. The type of the transducer is used in the motor field with the transductor. Other applications of the transducer are detection of the current with the dynamic braking grids with the locomotive equipped with extended range dynamic brakes, detecting brake signal in the field loop with the locomotive is equipped. Alright, two reactors of the type figure shown through Figure 1-3B are used to make the voltage of the governing voltage transducer with the flow of the alternating current AC coils with the voltage transducer. Reactor 3 and 4 proportional to the flow of the directive of the current coils. 1 and 2 the current with the 1-2 coils, the proportional main generator volt flow of the AC with the 3/4 with the proportional main generator voltage. Alright, so you have your current voltage transductor reactors, main generator volts, generator voltage transducer, AC terminals, gapless ion core, current with a gapless ion core, and the AC current with the governing current transducer. Alright, Figure 1-4, Figure 1-4 shows the result of the unified rectifier D14 current battery field excitation without the benefit of the controlling device. It can be seen with the graph that the current received with the D14 would be greater than the capacity of the battery field. Also seen that no control of the lever, excitation engine, load control of the train handling would be difficult. Alright, here you have a whole bunch of rectifiers, which are pot heads. You have your fuses and double gated way battery field alternator, main generator, battery field, shunt field, and your D14 alternator. Your Figure 1-4 shows the D14 current used for the excite battery field without reactors. Alright, Figure 5-1 shows the drop of the battery field current caused by the additional loading and windings of the three magnetic reactors F FM, field magnet 1, field magnet 2, field magnet 3, but the circuit shown in Figure 4, Figure 1-4, in addition to the loading windings, resulting with the constant current approximately 50 amperes running 8, but the current within the capacity of the battery field is not to be provided with a note that the current always passes with the reactor windings through the odd and even 1 to 2, the 3 to 4, and this key is operation magnetic simplifiers. Here you have a dilator alternator with a pot head and your field magnetic windings. Also a double gauge flip with two fuses. A magnetic field with around the main generator and shunt field. Figure 1-6 shows the part of the circulatory required control of the low of the battery field, but the first step of the control is additional base current reactors. 200 turn control winding of each of the reactors with multiple purpose. The winding is about 135 to 160 milliamperes of control current. The current flows from 8 to 7 even to odd. This current is direction opposite the flowing of the load windings. 1 to 2, 3 to 4 is the opposite flow of the current of the load windings. This increases the impedance of the reactor, resulting in the flow of 1.5 amperes left for the battery field. There is no sufficient proper exciting main generator polar train. Alright, you have your field magnetic currents on the auxiliary generator with a rheostat 1. Once again, the alternator, two fuses, double gate, 6 different field magnetic voices rectified into a battery field, and then a shunt field with a R reluctor. Figure 1-7, completely turn the battery field standard current with the accomplished load regulator excited with the 500 turn control winding each regulator's direction from 11 to 12. The current is opposition to the flowing of the 8 to 7 winding, result of the lowering of the impedance for the field magnet 1, 2, and 3. With the rheostat 2 adjusted with exciting with 11 to 12 winding, 60 to 770 milliamperes. Proper battery field amperage will be result from 80 volts across the battery field. The governor will now have complete control of the engine load, proper training, and the possible. Alright, once again, you have the alternator, 2 fuses, a battery, double battery gate with a field split into 2 lines with the parallel circuits of the field magnet 1, 2, and 3, and 1, 2, and 3 with a rectifier going into the battery field, with a rectifier and a main generator shunting field. And the effect of the adding of the reactor driver to, it shows the field magnet 1 and 2, they're different, 8 and 7 windings, positive to negative, odd to even, auxiliary generator, rheostat, load generator, maximum field. Alright, the characteristic excitation system described up to this point similar to those of communicator type load regulator, except the increase of the range of power with the GP35 control system includes the circuitry accomplished from the following. In series parallel motor connection to compensate for the fluctuation of horsepower to do with the variation quality conduction of the fuel, ambient temperatures, air pressure, metering of the fuel with the injectors, regulators provided with the optimum power of the train speed, battering approximately 12 to 8 miles per hour. Allows continuous operation of the speed range, regulates power of the main generator at speeds below 12 miles per hour, allowing the GP35 to work at an optimum speed in extending periods. The characteristic of the GP35 control system allows the compensation of fluctuation horsepower regulated horsepower overrides to the engine governor load regulator, which measures the field position where the compensation regulator characteristics is in effect. The characteristics maintain the use of the main generator voltage transducer, or GVT, a main current transducer, and from 4 to 1 transformers, and 2 rectifier bridges, and CR20 and CR21 to 2 rheostats, RH4 and RH7 as performance control. And the what is the PLR? Sorry about that. What is the PLR? Power load regulator. Power load regulator. PLR is power load regulator. Adding a performance control power load regulator. Figure 1.8 shows how the main generator transducer of the governor current transductor is used simply proportional to the main generator current. The core of the generator current transducer capless firmly clamp around the main generator bus. The flux density degree of the saturation of the core is the proportion of the level of the current main generator. Follows that the level of the AC current which passes the coil wound with these cores will also proportionally generate current with the current is passed with the primary winding X1 and X2 with the transformer 3T3. If a short circuit is placed across the secondary, the HV4 and H current with the primary will be proportional with the generating current. Generating current is shown in the graph figure of 1.8. Alright, your main generator currents going through currents 1, 2, and 3, and 4. A governing current transducer 1 and 2, 3, 4, and these small S and Fs. Your alternator from the main generator going off the governing transducer into the current transducer iron core. Current feedbacks is illustration. The secondary transformer is added with the circuit with the figure 1.8 is a step toward backing towards easier. The second current T3 circuit current is a rectified with the UCR loaded with the HRS7. Alright, here you have your diameter alternator going through 2 different things in the governor transducer to the main line current from to motors 1, 2, and 3, and 4. Also, the alternator runs a line with a transducer iron core which fills up 2 rectifiers. Goes through 2 different lines for a rectifier at rheostat 7. Current feedback system figure 1.9. Alright, in the circuit shown in figure 110, there is a usable signal DC voltage across the loading rheostat R7. The proper rule, though the resistance is shown with the rheostat, it's adjusted to give a 74 volt DC signal at the 3600 amp of the main generator. The main generator can be shorted with the circuit, then seating the main early mounting a 2000 ampere shunt to the right of the load of the shunting panel in the background. Alright, your main generator, the shunting circuit, and the shunt meter stuck right in between of the main generator and the 4 traction excitations with the alternator going through a transducing core and hitting off at rheostat at the with a voltage of 74 volts at the generator circuit. Figure 110 current feedback system. Figure 11 means it has been updated the DC voltage single proportional main generator voltage manner similar to those used in the generator current signal. To obtain the voltage signal and current proportional generator volts passed with the coil of the transducer with the governing voltage transductor and the governing current transductor. AC current secondary coils. These cores will be proportional main generator. The current is transformed to rectify pass with the RH4 1950 volts. Where available, the RH4 adjusted to give the 74 volt DC signal. In practice, for the HR setting of the obtained with the MG setting of the short circuit main generator with the rheostat adjusted with the general voltage ampere values and followed with the power limit line. See lower portion of figure 1112 and figure 46. Alright, figure 1112 shows the feedback signal volts and DC through the volts and its climb and acceleration. Then the rheostat, that would be like rheostator right there for the rheostat 4 and 7. Once again, you have your main generator, also, which is it goes through 2 conductor transducers with a zone line with the D14 alternator with going I guess, not looking at the cutout lines, the main generator has 2 different iron cores, and then it has another iron core, and then 2 rheostators before the voltage goes back to the DC. Figure 112, 2 feedback signals and connected with the series. The voltage added increase similar to obtain the connection of the 2 batteries in the series. The straight line drawn back with a 1950 volt point with the voltage feedback is equally to 74 volts and 360 amperes point with the current feedback signal is equal to 74 will feed the sum of the 2 signals equal to 74 volts any point on the line. It is not concedence that the straight line is closely parallel to the portion 2500 H horsepower curve that is used in the series parallel motor connection. Alright, down here on the bottom of figure 112, you see the current plus of the feedback signals from 115 volts to the main generator amperes. The sum of the voltage drops across the rheostat are 4 and 7 equals 74 volts at any point of this line. So, alright, you have rheostat 4 and 7. These are running on 74 volts. Your main generator, also your rectifying field currents 1, 2, and 3, and 4, all set up nice and neatly with the governor voltage transducer. Your governor current transformer into the diameter, while also going through a iron core from the alternator to the rheostat number R7. And same thing's going on, but there's 2 different transformers, and then a line, one of the transformer lines, the field winding, one of the linings goes from the main generator, the other one goes from the alternator into rheostat number 4. Figure 113, sum of the 2 feedbacks is compared with the voltage potential load regulator arm that does done connection with the 2 negatives together with the positive side of the feedback signal. Load regulator arm through the coil of the polarized relay, the polarized load regulator, unbalanced voltage load regulator arm with the feedback signal will result with the current flowing of the power load regulator coil with the current flow with 1 to 30 current power load regulator coil will cause power load regulator contacts 8 and 2 to open. This results in major reduction in magnetory amplifier current in the battery field excitation is reduced and resultant reduction in generator output. Close. Alright, you have on your 3 polar load regulator classes closes 8 and 6 and opens 8 and 2 on a 3 on 3. Alright, your power control series parallel shunt at 1950 volts to the main generator amperes of 3 to 3600. Alright, looking for the common negative on the auxiliary generator with the load regulator, so rheostat, hooking up the maximum field at 74 volts to the power load regulator, 70 volts to rheostat 2 and 4, and then rectifiers into iron transformer coil T4 and T3, following an outside line of the common negative in the each parallel from the main field and then into the rheostat, or two a fuse box and two rectifiers, one going each way through the a loop parallel current with the field magnet 1, 2, and 3, which has the L to 11 to 12, 11 to 12 openings. Alright, the rectifier around the field magnet 11 and 12 coils are 10 plate ciliums. Each plate conducts half a volt is amplified, but the 5 volts must be applied before the rectifier conducts. Since the DC current control of the RH2 applied with less than 3 volts, the rectifier has no effect on the control signal. AC current to develop the magnetic amplifier 1, 11, 12 has been rectifier suppliers. Alright, figure 114 depicts the condition where the engine output should result of the feedback signal only 55 volts, since the load regulator maximum field of the voltage of its arm at 74 volts compared with the 55 volt feedback signal current flows of 3 to 1 polarized load regulator coil polar load regulator contacts 8 and 2 closed, resulting in a full drive in the magnetic amplifier. Power load regulator contacts 8 and 2, and the resulting full drive in the magnetic amplifier. The full battery field excitation feedback voltage equals 74 volts. The follows the governor can control load on the engine, merely moving the load regulator. The system reacts rapidly fluctuation in power output signification. Once you see the auxiliary generator going to the load rheostat in the main field, 74 volts going through 3 to 1, 55 volts in a power load regulator connection. Going to rheostat number 4, and then into 4 different rectifiers on 2 different circuits in a TH transformer 4. Also, the rheostat number 4 goes in follows to rheostat follows on a parallel circuit with the rheostat, which goes through 3 rectifiers to transformer number 3. All right, from the rheostat. The load regulator, the rheostat, goes from the common negative, the outside auxiliary generator, to 2 rectifiers at 2 to 6, and then fuse, and then through 11 to 12 in different windings. Figure 14 shows the power less limit with 1950 volts at 300 to 600 amperes, and output of the less than 74 volts is due to reduce the throttle wheel slip extension. Alright, the second function of the performance of the control of the system, the regulation provided with the optimum performance of training speed between the 12 and 18 miles per hour. The accomplished change of the slope of the feedback signal line. This is done by the rheostat RH and RH5 and RH6. And the field shunt auxiliary relay FSA contacts M1 and N12. Note that ARH5 is indicated with the foregoing illustration field resistance that was done to avoid the unnecessary complication of the power explanation. Previously, text covered the performance control of the locomotive speed above 18 miles per hour. Therefore, the motor field shunting with occurred with the field shunt auxiliary relay was picked up with the field shunt auxiliary picked up with the rheostat 5 loaded with the T for terminal 4. Transformer 4 rheostat 6 is shorted out. Opening the field shunt auxiliary relay N1 and N2 contact the DC voltage drops across the loading rheostat 7 along with the rheostat 6 plus the rheostat 7. Change the anchor point of the power line from 3600 to 2550 amps, closing the field shunt auxiliary contactors M1 and M2. Change the DC voltage from the across for the RH4 and RH plus 5 to cross the RH4 alone. This changes the anchor point for the power line from the 1950 to 3250 volts. The power line is identified with B. This is an effect of the field shunt auxiliary is dropped out in the series of the parallel fold operation. The effective portion of the line is shown the darker than complete in its upper limit, which is Third function, performance control system regulating power main generator. Originally 2,000 horsepower, locomotive speed 12 miles per hour to allow the locomotive at work. Optimum speeds, power, the adhesion consideration accomplished and aging the slope of the feedback signal line that's done through the rheostat RH11 and RH12 rectifier CR is shown in the figure 116. Alright, the voltage, sorry, I read that wrong. The effective portion of the line is darker with a complete line with the upper limit of 1,000 volts, which is the voltage limited over the main generator of the power limit, is explained with the following text. Alright, you have your field relays, auxiliary relays to two different rheostats, RH5 and RH6. From RH5, you go to the polar load, power load regulator coil, RH4, two through rectifiers, which are in a positive negative connection of the transformer 4, and rheostat 6 and 7 on the negative side goes to the rectifiers to the power and negative on both sides of the power and negative of the T3 transformer conductor. The third function of the performance control system regulating with the main generator normally 22,000 horsepower locomotive speed below 12 hours per hour. 12 hours per hour allow the locomotive to work at the optimum speed, power for the adhesion consideration accomplished for the gain, changing the slope of the feedback of the back signal line that's done through the rheostat RH11 and RH12 rectifier CRN shown in figure 16. RH12 and connected with the voltage divider of the 74 volt source of the PA wire that establishes the potential to leave the CR39 through the signal of the T3.A with the potential established setting of the RH12. The load T3 is changed effectively adding resistance total the RH12 and RH11 plus the RE29 parallel the RH6 and RH7 circuit. Power lines make a sharp bend and the RH12 is obtaining the bend of the locomotive at a speed 12 miles per hour. Alright, the slope of the line after the bend is determined by the RH11. The RH11 is back, bringing about the slope that is very close to the arrangement of 2,000 horsepower. Note that the bend beyond the slope of the line is changed with the railroad obtaining verified performance characteristics as desired within the limits. Figure 116 shows 200 horsepower control at 3,000 to 2,550 amps under 18 miles an hour and 2,000 to 4,000 horsepower volts or amperes. 74 volts DC going through the PA wire going in through the B shows the power line side. The rheostat 12 going into what looks like a two-phase reductor or 4 different rectifiers, the RH11 through field auxiliaries, N1 and M12 split at the parallel for the parallel closing of the RH5 on the M12 side, the RH6 on the N2 N1 sides, and then you have from the RH5 and the joints of the RH6 and transformer. You have transformer 4, which goes through rectifiers before it hits, and then you have rheostat RH6 and RH7 on a parallel circuit with the T3 transformer 3. The negative line from the RH12 going to the RH7 and the R2 323.9, which was a parallel to the rectifier housing, poor sharp bend. Figure 117 depicts a use of the performance control circuit. The control limit of the main generator amperes through the traction motor field during the dynamic braking. The brake contacts direct with the power load regulator with the load regulator control with the connect the power load regulator Zener diode with the 24T with the power wire from the brake control rheostat. The voltage feedback signal with the the voltage feedback is cut out at BKP1 interlock. Rheostat is inserted with the current feedback circuit with the BKP1 interlock. 2,000 horsepower control with the RH11 and ARH12, and the CR9 does not go into effect with the dynamic braking because the signal of the T3 never exceeds the potential brush arm of the rheostat 12. Alright, the generator resolves with the feedback signal with the greater the signal, but the brake controls rheostat. Polar power load regulator contacts closes 8 and 6 interprets the current magnetic amplifier driver coil. If the generator current exceeds 975 amperes, the current feedback signal is greater than the maximum signal with the brake control rheostat. This limits the maximum of generator current. Dynamic braking circuits are further explained in Section 3 of this handbook. Eliminating the voltage feedback signal results in vertical limit shown on the graph. Figure 17 shows the dynamic braking current with the voltage from 50 to 0 to 75, but stops at 50, and to the left about 975 amps are left on the line using dynamic braking. It shows the main generator amperes fully and the voltage of the power regulator of 75. Alright, once again, you have your auxiliary generator on the out end going through the first series of parallel currents of the load regulator. And then on the outside of the auxiliary branch, you have the BR relay, 2 BR relays with a rheostat. I guess that's marked with an R. 24 wire reverser, rheostat, field gate, polar load regulator between 6 and 8. And then field magnets 1, 2, and 3, and 4. It loads 11 and 12 contacts. Your brake control power control fuse through the power load regulator, going through 2 rheostat 6, 7, and then a 8 rheostat 3 on a brake power connector relay, and then CR and CR3 with a transformer 3 inside the rectifying circuit. Alright, figure 2 shows the transition program switch cam development chart, the FTR, BTR, powered PTR operation values. Alright, from the collection of the Tom Gardner from the Warren from rr-flyonflags.org website. Section 2, transition controls.